Okay guys, welcome back. We're in Unit 4A. Today we're going to be talking about a couple things. The first of them being quadratic inequalities. Transformations will come up later. So we have to actually take two little sections and put them into one. Okay, so we're going to be graphing to start off today's lesson. Remember that standard form is ax squared plus bx plus c. To find the vertex is a little bit tricky. Remember that you need to first find the x by using that formula, negative b divided by 2 times a. Then plug that number into the formula to find the y of the vertex. Number 2, the vertex form, when it's given to you, is the one with the parentheses. And remember that the vertex is hk, where h looks opposite because of the minus sign in front of the h and the formula. Okay, number 1. We're just going to graph these. Now we do have to find a table of values after we find the vertex. So this guy here is in vertex form because I see parentheses. The k is not there, so I'm just going to pull up 0. So the vertex here is h is -4, k is 0. So I want to go ahead and plot this point, -4, 0. Then I want to go back and get a table of values, xy values. Now you have to carefully choose your x's. Remember, you choose at least 3 values, and you look at the -4 first. That determines what x values you choose. So choose the 3 numbers that are after it, such as negative excuse me, -5, -6, -7, or -3, -2, -1. And then you use the formula 3 times and do a little bit of math to find the y's. So we'll do -3 plus 4 squared. I'm using the formula. And that is 1 squared, which is 1. Then I'm going to go ahead and erase that. I'm going to do work again with the -2 in for x. So that'll be, add those up and get 2 squared is 4. So there's another point, erase that. And then I get my last point, take -1, put it in for x, do the math. -1 plus 4 is 3, 3 squared is 9. Okay, now I go ahead and plot those points. We have -3, 1, -2, 4, and -1, 9. And now we need points on the other side. Let me draw my axis of symmetry. Remember, it's the dotted line here that goes through the vertex, splits up the left and right side. So I need to choose points on the other side of the axis here, and here, and here, just mirrored points to draw my vertex. Now, this is an inequality problem. We throw in a new wrinkle today. Check that out. We got a y is less than back here, okay? So that guy, remember when you have no underline there, that's going to be a dashed line. So we draw our dashed line. Nice smooth curve. Make sure your line parabolas go to the edges. And there has to be shading here. So remember, the shading is determined to be above or below. So that's a less than. That means it would be below the parabola. Now, it doesn't mean like below the vertex. It means view the parabola as being one huge line and just shade everything below it. It looks around, but we technically say this is below. All right, and then that's done. If anyone were to ask you to name solutions of it, you would name any points in the shaded area. Okay, let's try another one. Example 2. This guy is unfortunately in standard form. I say unfortunately because we got to do a little bit more work to find our vertex. We have to use that little formula, x equals negative b over 2 times a. And the b here is 4, so we would say negative 4 over 2 times the a is negative 2. So we're going to multiply on the bottom and then divide to get 1. So that's the x-coordinate of the vertex. Now we need the y-coordinate of the vertex. We're going to take that 1 and plug it into the original formula. And we do need to use order of operations. Remember that exponent comes first. So we're doing 1 squared, which is 1. Then we can multiply. We can multiply here and here to get negative 2 plus 4 plus 3. And then, of course, we can add those together. Negative 2 plus 4 is 2. 2 plus 3 is 5. So that gives me my vertex finally being 1, 5. Obviously, you'll be a lot faster than I am because I'm explaining this as I go through. All right, so let's plot that vertex. We got 1, 5 right here. I'm going to draw my axis of symmetry. So that axis of symmetry goes through the vertex all the way up and down. So now I need more points. I need to go, just like the previous problem, I need to go to my table of values. I need to choose some x values. So my first x value, remember we look at the x-coordinate of the vertex, which is this guy, is 1. After 1 comes 2, 3, 4. All right, so I'm going to start with this 2, plug it into the formula for the x's. Exponent always first. Remember PEMDAS, exponent before multiply. So 2 squared gets 4. Now I can multiply my 2 times that's showing multiply, multiply, and then I can add, and that will be 0 plus 3 is 3. So erase all of that. And I'm going to do the next number, 3. We'll go in for x. Exponent first, 3 squared is 9. Multiply and multiply, this is negative 18. And then add and add. And then finally the 4 goes in for the x's. So exponent, 4 squared, 16. Multiply, multiply, and then add those together. Add up to negative 16 plus 3 is negative 13. And then get rid of this. So we have our table of values. We can go ahead and graph those points. We got 2, 3. 3, negative 3, and 4, negative 13 is way off the graph, so we're not going to worry about that. So we put points on the other side of the axis here and here. Now, again, this is, look at the top of the page right here. Okay, that is a inequality. That has, so that one's less than or equal to. When it has the or equal to the underline, that's going to be a normal solid line. It's a really ugly parabola, but go with it. Solid line, and this guy would be shade below which looks inside, but it is technically below the parabola right here. Okay, example 3, back to a somewhat easier one, much easier to find the vertex. It's HK, so that would be -3, H is opposite, and 4. So we got -3, 4. Let me draw on my axis of symmetry. I hope you guys are rewinding if you need to. If you miss something, make sure to go back and rewind. So there's your invisible axis of symmetry. Now what do we need to do is get our x value table, xy. All right, what x value should I choose? So here's -3. So 3 numbers after -3 are -2, -1, and 0. So now I'm going to use my formula and find the matching y values. So let's start with the -2. So negative. Okay, again, careful with the order of operations. You need to do parentheses first here. So -2 plus 3 is 1. And then after parentheses is done, it's down to one number. You should be doing exponent next. So that drag down the negative. And then 1 squared is 1. After that, you can say technically is multiply. The negative times the 1 will be -1. And then add to get 3. And now let's do the same procedure, same steps as we did. So let's take the -1, plug it into the equation. So what's first? Parentheses, add those to get 2. After that, exponent. So that would be bring down the negative, and then 2 squared is 4. Now you can multiply negative times 4 is -4. And then they add up to 0. And then finally the 0 plugs in for the x. So carry the negative, you're doing parentheses first. 0 plus 3 is 3. And next is exponent. So carry down the negative. 3 squared is 9. So it becomes -9 plus 4 is -5. Now we can plot those points. We got -2, 3, -1, 0, and 0, -5. And then we get the matching points on the other side of the axis here, 2 and 3. Now, what is this? Solid or dashed? Look up here. We have no underline. This is greater than, so that's going to be the dashed line. Wrong one. Dashed line. And the shading, it's a greater than, so that would be above the parabola. And there, it is done. Okay, I want you guys to try the next one on your own. So, the vertex here. Remember, I did tell you a huge tip the other day. When the B is 0, the vertex is 0. So if we take a look at this, you could view it like the B is missing because there's no X term. Okay? That's what the A is -1, B is 0, C is 6. And I did tell you the other day, when the B is 0, the X coordinate is automatically 0. Because if you were to use your little formula, it would be -b over 2 times A. That would be 0 over -2 is 0. So then you take the 0, plug it in to the formula for the X. So that would be -0 squared plus 6. And that'll be 6 for the Y coordinate of the vertex. Okay, from there, let's plot that point, 0, 6. I'm not going to draw the axis of symmetry because the y-axis will serve as that. So let's go to my XY table. X values to choose. My first X value up right here is 0, so let's go with 1, 2, 3 in this problem. So let's go, okay, we're going to use the formula again, -1 squared plus 6. Remember, you want to do the exponent first, so bring down the negative, and then 1 squared is 1, and then that's -1 plus 6 is 5. So throw the 5 into your table. Now let's use the formula again. Take the 2 in for x. Remember, use parentheses when you're subbing numbers in for x's. Parentheses are there to help you. So exponent here, that would be the 2 squared. Bring down the negative, and then 2 squared is 4. So then -4 plus 6 is 2. And then finally the 3. -3 squared plus 6. Bring down the negative. 3 squared is 9. And then -9 plus 6 is -3. Let's plot those points. We got 1, 5. We got 2, 2. And we got 3, -3. Then on the other side of the axis, 1, 2, and 3 over. All right, do we have a solid or dashed parabola? So you're going to look here. That's greater than, so that's going to be a dashed. There's no underline there. And the shading. Greater than, that would be shade above the parabola. So again, if you had a side question that said name a point that is a solution to this, you would just name any point that is in the shaded area. Do not name a point that would be on the dotted line. Remember, points on the dashed line are not part of it, but if it was a solid line, points on the solid line would be solutions. Okay, I'm gonna not, yeah, what the heck, I'll go in the next part, I have enough time. So we're gonna be describing transformations in vertex form here on page 20. Now, we can look at, what's special about the vertex form is we can look at it and kind of get a rough idea of how that parabola were to look if we were to do a rough sketch of graphing it. So describing transformations is like saying, hey, does it open up or open down? Hey, does the vertex shift, up or down or left or right a number of units? Is the graph, stretched out and looks thinner, or is it compressed downward and looks a little wider? So we can look at the numbers in those, and that's right here. So the A determines if it opens up or down. If it's a positive, it opens up. If it's a negative, you must write that it opens down. So if A is a negative, you must write opens down, also known as reflection. So if A is a negative, you can put reflection instead of opens down if you want. Now, stretch or compression has to do with A also. Whenever you have a number greater than 1, such as 2, or even a negative, like -3, or 4, or -5, whenever that you have that for an A, you're going to write stretch. That would be a vertical stretch. It appears to be thinner. It's just stretched upwards or downwards. Whenever you have an A that is a fraction or decimal, such as 1/2 or -3/5, like if it's a number whose absolute value is between 0 and 1, then you write compression, meaning it would be smushed down and appear wider. The H has to do with if the vertex shifts left or right, and the K has to do with if the vertex shifts up or down. So here in example 4, the directions say, describe the transformations when the graph is compared to y equals x squared. That just means we're going to write down whatever these shifts are. So what do we have here? We have an x plus 10 squared. That looks like an h according to the formula. X plus 10 is in parentheses. So we only have one shift here. That would be when you have x plus 10, that's shifts left 10. If it shifts left or right, you've got to put the number of units is shifting left or right. Same thing with up or down. By the way, I know some of us will look at the plus 10 and go, oh, that's to the right. But remember, h is opposite, even with that formula with transformations. Okay, example 5, the x squared plus 3. If we take a look, that plus 3 is not in parentheses. So that guy there is a k. So that has to do with shifting up or down. So when a k is a plus, we're gonna write shifts up 3. All right, example 6, we have some more shifts here. Now we have our first one. We actually have 3 transformations here. Look right after the equal sign, and you see a negative. That A is a negative, an invisible -1. So that's our first guy where we are going to write opens down. Also known as a reflection. Meaning if instead of a U opening upwards, it would be basically an upside down U if we were to graph. I should have left myself some space, because I have 2 other shifts here. The x plus 7, that's in plus 7 in parentheses, that is left or right shift. So just like the one directly above it in example 4, that's a shifts left 7. And then a -10, that's all by itself at the end. That is a k, so that is a shifts down 10. Example 7 has 2 shifts. The 1/3 is the A. We discussed earlier that when you have an A being a fraction between 0 and 1, that is a compression. And x minus 2 is in parentheses. That has to do with the h, left or right. This guy is our first shifts right. Shifts right 2. Example 8, we have 3 transformations here. 7, that's in the spot where A is. A is 7, and is a number bigger than 1. That is what we call a vertical stretch. After that, we have x plus 5 in parentheses. That's an h left or right. That would be our third of the page. Shifts left 5. And then the plus 3 at the end, that's the k. Shifts up 3. And then finally, I want you to take a pause and try this one on your own. I'll give you a hint. There are 4 transformations here. So the A is a negative, so that means it's a, you can either write reflection or opens down. Either one is good for me. It's also a 1/4, that's a fraction between 0 and 1, so that is also a compression. And then you look to the parentheses and go, okay, x minus 8, that's is that left or right? In parentheses, that would be a right 8. Make sure to put the 8 if it's shifting right. And then it's also shifting down. Look where the k is. That's a minus 6, so you're going to write shifts down 6. Okay, and that's it for my lesson.